Virtual reality, or VR, is a technology that immerses users in a computer-generated environment, simulating a real or imaginary world. It works by combining hardware and software to create an experience that tricks the brain into feeling present in a different environment. Here's how it works. First up, the hardware components. The head-mounted display, or HMD, is the most essential component. It covers the user's eyes and provides stereoscopic, three-dimensional visuals. Each eye gets a slightly different image, mimicking how our eyes perceive depth in the real world, creating a sense of immersion. High-resolution screens, one for each eye, are placed close to the eyes. Lenses between the screens and the eyes adjust the image to make it more natural. Motion tracking sensors, like gyroscopes and accelerometers in the HMD, track the user's head movements in real time. When you turn your head or look around, the virtual environment responds by changing the view accordingly. Some systems also use external sensors, such as cameras or infrared sensors placed in the room, to track body movement and position. Handheld controllers, gloves, or even full-body suits can track movements and provide haptic feedback, allowing users to interact with the virtual environment through actions like grabbing, pushing, or throwing. Next, let's talk about software and rendering. The software creates virtual environments using three-dimensional models. These could range from realistic representations of real-world objects to entirely fictional worlds. The three-dimensional environment is continuously rendered and updated as the user moves. The VR system's software, often powered by a game engine like Unreal Engine or Unity, handles the real-time rendering of the virtual environment. This ensures that the visuals respond to the user's actions instantly, minimizing latency, which is crucial for a smooth and immersive experience. The field of view, or FOV, is the angle of vision in the virtual world that the user sees. A wider FOV, usually between 100 to 120 degrees, makes the experience more immersive, simulating peripheral vision. Lastly, tracking and movement. VR systems offer 6 degrees of freedom, or 6 DOF, allowing users to move forward and backward, up and down, left and right, and rotate in all directions. This is key to creating a fully interactive environment. Some advanced systems allow the user to physically walk around a room, with external sensors tracking their position in space, expanding the freedom of movement. Audio and haptics play a crucial role in virtual reality. Spatial audio, for instance, is essential for immersion. It simulates how sound behaves in the real world, making sounds louder or softer depending on the user's position. So, if something is happening behind you, the sound will come from that direction. Haptic feedback is another key element. Many VR systems use it to simulate touch and force. For example, if you pick up an object in VR, the controller might vibrate to give you a sense of physical interaction. Immersion and presence are fundamental concepts in VR. Immersion is achieved through the combination of high-quality visuals, sound, and responsive controls, creating the feeling of being inside the virtual world. Presence, on the other hand, is the sensation that you are truly in a different environment. The more convincing the immersion, the stronger the sense of presence the user feels. Latency and frame rate. Latency is a crucial factor in VR. It's the delay between a user's action, like turning their head, and the system's response. Low latency, under 20 milliseconds, is necessary to prevent motion sickness and ensure smooth interactions. A high frame rate, ideally 90 frames per second or higher, is also essential to maintain a fluid, believable experience. Interaction and feedback. Users can interact with the virtual world using hand gestures, controllers, or even their entire body. For instance, they can pick up objects, press buttons, or explore the environment. The VR system continuously updates the user's position, movements, and actions to provide instant feedback, keeping the experience consistent with their actions. Applications of VR. Gaming is one of the most popular applications, where users can experience immersive gameplay. In training and education, VR is used for realistic simulations in fields like medicine, aviation, and the military to train professionals in a safe virtual environment. For entertainment, virtual tours, concerts, and movies can be experienced in VR. Therapy is another area where VR is used for psychological treatments, such as exposure therapy for phobias or PTSD. Lastly, in design and prototyping, architects and engineers use VR to visualize projects in 3 dimensions before they are built. By blending all these elements, VR creates a convincing and immersive digital environment that can transport users to new worlds or simulate real-life experiences in ways that feel tangible and interactive.